Hey students, it's time for our fifth lesson about dividing with fractions. Today's I can statement should look really familiar. We use something similar when we are multiplying fractions. So it says I can use common factors to simplify before dividing fractions. We had the same I can statement a couple of days when we were learning how to multiply fractions. So if you watched the last video, you know that dividing fractions is almost exactly like multiplying fractions, except we have one step before we do the multiplying. All right, so let's get into it. Here's our first problem. It says 8/9 divided by 2/3. Last week we did a lot of problems in synchronous where we did pictures and we took out equal groups of things, right? So when I get to problems where I just have a number divided by another number, I've got to slow down my brain. I've got to think about what this problem is asking, and I have to have a visual representation so I know if my answer makes sense. So here's what I mean. 8/9 divided by 2/3 means nothing to me, right? Dividing problems are hard to visualize, and it's got fractions on top of it. So I'm going to flip this question a little bit into this. How many 2/3 do I need to make 8/9? Or how many 2/3 will make 8/9? I also want you to notice that the order of the fractions has kind of changed. 8/9 was first, but now it's at the end of this sentence, and 2/3 was the second fraction, and now it's the first one. All right, so remember with division, we start with the total. Grab a different color here than that, like gray. This is the total. And this second number, this 2/3, tells us the size of each group. The size of each group. So what I really need to know is 8/9, is that bigger than 2/3 or is it less than 2/3? So am I taking out giant groups or big groups out of a small number, or am I taking smaller groups out of a big number? All right, so here's a way to say that. Here's a picture of 2/3, right? And here's a picture of 8/9. I want to know, taking a look at just this yellow part on the top, this yellow part, can I get this yellow part to go right down inside of that purple part? Will at least one of these yellow pictures, will it fit inside of that 8/9? And the answer is yes. If I draw a line at the end going straight up and down, you can see that there's some leftover purple here, right? That's going to end up being our remainder. But this yellow part fits in at least one time. We know it's going to be at least one, plus a little bit more, right? So this yellow group, this is what I'm asking. How many of these yellow things can fit inside all of that purple? It can fit inside one time with a little left over. So our answer to this problem should be a little bit more than one. So let's try it out. So here's the exact same problem that we did above. 8/9 divided by 2/3, or how many 2/3 are in 8/9? And we just said the answer should be a little bit more than one. A little more than one of those yellow chunks will fit inside that purple part. All right, so now I'm ready to just do the division. And to do that, I need to remember that video that we watched the other day, right? The lyrics said, if you want to divide. So the very first thing I have to do is I have to double check, is this a division problem? And it is. Let me grab a different color. I like this gray one. All right, so this is a division problem. I know that seems a little bit silly because clearly they're going to be division. That's what we're learning about today. But there's going to be a day coming up where we have both multiplication and division. So please double check. If you want to divide, and it does say division, all right? Then the next part says, look on the right side. So now I've got two fractions here. I need to know which one is on the left and which one is on the right. If you're right-handed, it's a little bit easier, all right? I just take my right hand and I see that it is on the right side of my body. I don't know. This is my right. So that means the other one is the left, all right? So I'm just looking at this fraction. The next part of the sentence only has to do with this fraction because it's the one that is on the right side. All right. So then I'm going to keep on going. Find the reciprocal. And we talked about this in class. The reciprocal means flip it over. So I'm going to draw an arrow to show that I'm flipping over just that highlighted one. I'm not flipping over 8/9, and I can't switch the order. But instead of the 2 on top of the 3, I'm going to have 3 on top of 2, and I'm going to write that down below. 3 on top of 2. You can see now how that got flipped over. The 2 was on top, now the 3 is on top. The 3 was on the bottom, now the 2 is on the bottom. All right, I am almost ready. Whoops, let's go back to that. 2, and the last step, and then you multiply. So now I'm going to go back to this problem, and I'm going to write 8/9, keep that in front, and then it changes to a times problem. So let me highlight that. It was division, now it's times. All right, now I'm ready to look for common factors. So I'm going to look at my diagonals. Unfortunately, I don't have any 1s, but this is cool. I have a 2. 2 is pretty easy to rewrite as factor pairs. So I'm going to write times. The 2 is on the right on the bottom, so I'm going to write 2 times 1. That's the only way I can write a times problem and get an answer of 2. I could write 1 times 2. Notice that's the same numbers, it's just opposite. So the 2 is the larger factor. 2 is bigger than 1. So I'm going to try to write 2 times to make the 8. So this has to equal 8. So that's 2 times 4. All right. So at this point, I can cross out my common factors because that's really the number 1 hiding inside. 2 halves. All right. Then I'm going to look at my other diagonal. I'm going to look at the smaller number 3. Ooh, this is good. There's only one way to write the number 3. That's 3 times 1. All right. So of those 2 factors, 3 is larger. So I'm going to try to use the 3 to make the 9. So this is going to be 3 times. 3 times something equals 9. Be careful, not 3 times 9, but 3 times 3 is 9. Right? And then I'm, whoops, put that 3 back. Then I'm going to cross out the common factors where the number 1 is hiding. So be really careful. If I cross out the number 3 once on top, then I can only cross out the number 3 once on the bottom. Now, I could multiply across, or I can notice that there's a 1 on the top and a 1 on the bottom. So I could cross out those as well. This is 1, not 1 once. This is 1 whole. And now this is all I have left. Grab a different color. There's a 4 on the top and a 3 on the bottom. That means this is 4/3. And we know that we can rewrite that as a mixed number by keeping the denominator the same and writing the times for mad. So 3 times something gets me close to this number 4. Remember, I'm trying to make 4. So 3 times 1 is 3. Then I need to add 1 more because 3 plus 1 equals 4. Let me rewrite that. 3 plus blank equals 4. That 1 is what we're in right there. Put it in red too. 1. So my answer is 1 1/3. Let's put that in maybe green. 1 1/3. And let's look back at the work we did on the previous page. Look at that. We said that our answer is a little bit more than 1 because that giant yellow piece fits into the purple piece 1 time, plus there's a little extra. 1 time is the purple, and the little extra is the fraction that's still left, the 1/3. All right, let's try another example. This problem says 2/5 divided by 7/10. But remember, our brains just can't comprehend that very well, right? So we need to change that question into how many 7/10 does it take to make 2/5? How many 7/10 are hiding inside of 2/5? All right, so here is 7/10. How many of these green pieces do I need from beginning to end, this entire thing all together? How many of these are hiding inside of that. Do you notice that the green part is a lot bigger than the purple part? Right? So if the green part is bigger than the purple part, if I drew a line going straight down at the end of my green, the purple part doesn't even get there, right? The purple part is smaller than the green part. That means my answer has to be less than 1. I can't even use this chunk one time to make the purple part. All right, so let's try it out. Same thing, we're going to do those steps. If you want to divide, I'm going to just double check. Yep, there's a division sign in between 2/5 and 7/10. All right, so I can keep on going with my song. Look on the right side. Grab a different color. So 7/10 is on the right side. Right. I'm going to find the reciprocal. Remember, that means that we're going to flip it over, but not both of them. Just the one that I highlighted, just the one on the right side. Flip it over. So now the 10 is on top and the 7 is down below. So instead of 7/10, now it's 10/7. And the last step, and then you multiply. All right, so we put the times in, and in front stays the same. That is 2/5. Again, notice this fraction in front doesn't change. I just flipped the second one over. Okay, so now I'm going to look at my diagonals and look for a common factor, right? So 2 is pretty small. So here's my diagonal, 2 and 7. I'm going to rewrite times, right? The only way to write 2 is 2 times 1. That means I have to use a 2 or a 1 to make this 7. I can't make 7 by saying 2 times. That doesn't work, right? If I count by 2, it'll be 2, 4, 6, 8. I'll skip right over the 7. All right, so I can't use that 2. So instead, I'm going to use the 1, right? So here's a 1, here's a 1, right? I need a common factor. So if I'm trying to make 7, that's 1 times 7. All right, then I'm going to get rid of that. And I can cross out the 1's, 1 whole. I just multiplied by 1. That doesn't change my answer. All right, now I'm going to look at the other diagonal. Here's a 5 and a 10. 5 is smaller, so I can make 5 by saying 1 times 5. And then I'm going to look at these two numbers. There's a 1 and a 5. 5 is the larger number, so I'm going to try to use 5 to make this 10. And I can. That's 5 times 2. All right, cross out my common factors. Here's 5/5. That's like multiplying by 1 whole. Here's a common mistake that kids make. They think that they can cross out this 2 and this 2. But I want you to notice that they're both on the top of those blue lines. They're both numerators. If you look at what else we crossed out, there was a black on top and a black on the bottom. There was a brown on top and a brown on the bottom. But these two 2's are both on the top. I can't cross them out. So now I'm just ready to multiply across. I'll highlight what I have left. Here's a 2 and a 2. 2 times 2 is 4. And then I'll highlight what I have left on the bottom. 1 times 7. 1 times 7 is 7. So there's my answer. My answer is 4/7. And if we look back at what we said on the last page, we said less than 1. Right? Less than 1 was our answer, and 4/7 is less than 1. All right. Just a quick little aside. 4/7 is a little more than half. Right? Because half of 7 is 3.5, and 4 is a little bit bigger. Or I could say 4/8 would be exactly half, right? And a 7th is a little bit larger than an 1/8, so 4/7 must be a little bit more than half, right? So here's what that means. If I found half of this gray part, I said gray, I mean green. If I found half of it, so there's 7 of them, so I need 1, 2, 3 and a half right here. Right? Do you notice how this purple part just goes a little bit more than that halfway spot, than that halfway line? That's what that means. All right. Our answer was a little more than half, because a little more than half of the green is what you need to make the purple. All right, we are going to practice this part, this screen, in our synchronous class.